In this video, we're going to be talking about graphing nonlinear equations. So before we actually get into the graphing part, I want to talk about what we call parent functions or parent graphs. And that's just the general shape that any graph will have if they're in this particular form. The first form that we see here is a linear equation, meaning the x and y variables will be to the first degree. There's no squares or absolute values or square roots or anything fancy going on. It's just an x and a y. And we've seen this in standard form and slope-intercept form. But any linear equation starts from the parent graph, y equals x. And then it gets shifted and rotated and stretched on the graph so it can end up anywhere on the coordinate plane. The absolute value function has a V shape. So any equation, any function that has an absolute value in it will take on this form. Again, that could be shifted somewhere around the graph. It doesn't have to start at the origin, but this is just the parent function before any shifts have happened. A quadratic equation will be a parabola. Again, that parabola could be facing up, down, shifted around, but if there's nothing happening, this is the general form of a quadratic before any shifts have happened. But as soon as you see the highest degree being x squared, it will take this form, this U shape. Next we have a cubic function, x cubed. So like the parabola, one side will have a curved up shape, but the other side will have a curved down shape. And now that is a cubic function. A square root function will have kind of half of a parabola turned on its side. So it looks kind of like a parabola, but only half of it. A cube cube root similar to the cubic function will have that half parabola going up and then a half parabola coming back. So see the resemblance? We have a quadratic as a U, and then the cubic goes up and then down. Square root has half of the U, and then the cube root has that half and then going down. And then lastly, we have what is called a rational function, but in this case I think your homework calls it a reciprocal function. And that will have a very unique shape as such. We won't do a lot with that in graphing with this class, but it's good to get familiar with it. And then a reciprocal squared, meaning we have x squared in the denominator, will have this sort of shape as so. Now if you can memorize the shapes, the general shapes, not the exact where they are on a graph, just knowing that a linear equation makes a line, an absolute value makes a V, a quadratic makes a U, so on and so forth. If you can get familiar with just the general shape of these parent graphs, it's going to help you to know if you've completed your graph when you go to graph it using a table by hand. For example, I have here f of x equals x squared plus 3. This is the key that tells me the shape I'm looking for. So the shape needs to end up being a U shape. It doesn't always have to go up. It could go down. It could be wide. It could be thin. But I just know it's going to be that shape. Now when we graph nonlinear functions, we definitely need to find more than 2 points. Right? When we talked about graphing linear, you technically only need 2. We recommend 3 to make sure you're getting that straight line. But with nonlinear, you need to get this full shape. So you will definitely need to find more than 2 or 3 points. So I can pick any points that I want here. we're just going to test some to figure out what's going on. So I'm just going to start with an easy number. I'm going to start with 0. 0 is a nice, easy number to work with. So when I plug in 0 in for x, or I could rewrite this as y if you're more comfortable with that. This is 0 squared plus 3. So y will equal, 0 squared is just 0, plus 3 will be 3. So there's a point, 0, 3. I'm going to get some points around that, because now I've got an idea where it's going to be on my graph. So let's pick the next point over. Let's pick 1. Now I'm going to have 1 squared plus 3. 1 squared is just 1, plus 3 would give me 4. So over 1, up 4. Let's keep going. Let's pick 2. So again, there's no exact science here until we actually get into the quadratic chapter about graphing. We're just picking some values, finding the y value that goes along with it. 2 squared is 4. 4 plus 3 is 7. So that's getting pretty big. So over 2, up, let's see, that was 4, 5, 6, 7. I'm almost off my graph here, so I'm not going to keep going right. Let's pick some points the other way, because I know I need to end up with a U shape of some form, and this is not the whole thing. I can't stop. So let's go in the negative direction. Let's pick -1 and see what happens. If I plug in -1, be sure to put in parentheses around that, wherever you plug it in. So I have a -1 squared. Negative times a negative will end up positive. Plus that 3 will give me 4 again. So -1, positive 4. So now I'm starting to see that U shape here. Let's do one more. Keep going in the negative direction. I'm going to pick -2. So wherever I see that x, I'm going to plug in -2. And I end up with negative times a negative equals positive 4, plus that 3 gets me 7. There should be a pattern here, because it should be a mirror image on the left and right side. And there you go. I see I have my parabola. So it ended up being the U shape that I needed. Let's look at this next example. This one is a square root. We know from the parent graph it should end up something like that. A curved kind of shape as such. So again, I'm just going to start with a nice easy number to see where I end up on that graph. Replacing f of x with y and replacing x with 0. Square root of 0 is 0. And 0 minus 2 is -2. Plugging in 0, I got -2. Now this is a square root. I can't take the square root of negative numbers, so I'm not going to go in this direction. I can't plug in -1. Square root of -1 is not a real number. So I have to continue on in the positive direction. I'm going to pick 1. Also taking into account that I am taking a square root, so I probably want perfect squares. I'm replacing x with 1, which is a perfect square. Square root of 1 is 1, and 1 minus 2 is -1. So I go positive 1 for x, -1 for y. That's not enough, because that looks like a straight line. But I know this has a curved shape, so I need to keep going. I'm not going to pick 2 or 3, because they're not perfect squares. I'm just going to go on to 4 and see what happens. So y equals the square root of 4. The square root of 4 is 2, and 2 minus 2 is 0. So I ended up going 1, 2, 3, 4 on the x, 0 for y. I can see I'm getting that curved shape now. If my graph was bigger, I might go on to the next perfect square, which would be 9. But that's going to end up being off my graph. But let's just see what happens. Plugging in 9 for x. Square root of 9 is 3. Minus 2 will give me 1. 1, 2, 3, 4, 5, 6, 7, 8. So somewhere out here and up 1. And there's my parabola. Or sorry, square root function. Alright, why don't you guys try some? Let's go through the answers for these. This next example has an absolute value. We know from our parent graphs, absolute value is going to end up in a V shape. So I need to end up with a picture in that form. Now I'm looking at this, I'm just going to start off with a nice easy number again. You might have picked something different, and that's okay. I'm starting off with 0. So we're replacing f of x with y. I'm replacing x with 0. When we talk about absolute values are distances. So 0 plus 1 is 1, and the absolute value of 1, how far away is that from 0? Still 1. 1 unit. And then 1 minus 3 would be negative 2. So I get the ordered pair 0, negative 2. Alright, let's keep going. Let's go ahead and go in the positive direction, see what happens. I'm going to pick 1. Replacing x with 1, so 1 plus 1, absolute value of all that, minus 3. 1 plus 1 is 2, and the absolute value of 2 is 2. 2 minus 3 is negative 1. So I go positive 1, negative 1, ending up there. So I can see half of a V. Let's go in the negative direction, see what happens that way. Replacing x with negative 1. Negative 1 plus 1 is 0. The absolute value of 0 is 0. And then minus 3. So I end up with y equals negative 3. So I went back, negative 1, down, 1, 2, 3. It's still going down. But I know I need a v. I need it to go back up. So let's keep going back in the negative direction. At some point, it has to keep going up. Or it has to go back up. I am replacing x with negative 2 now. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1. 1 minus 3 is negative 2. So y equals negative 2. I go back 2 on the x, down 2 on the y, and there it is. There's where I'm going back up. Let's do one more in the negative direction. Replacing x with negative 3. Negative 3 plus 1 is negative 2. And the absolute value of negative 2 is positive 2. 2 minus 3 is negative 1. I go back 3 on the x-axis, down 1 on the y-axis, and there is a complete V shape, but I know that it's going to continue on and on forever in both directions. So even though those are the only points I found, I'm going to continue making my graph so I fill the space. Alright, last one here. This is a quadratic again. I know it needs to be a U shape. I'm going to start off with 0. 0 is a nice number. Oops, you guys are replacing f of x with y, replacing x with 0. 0 squared is 0, so y will equal -2. 0 down 2 on the y-axis. I'm going to keep going. Let's go in the positive to see what happens. Plug in 1. 1 squared minus 2. 1 times 1 is 1. 1 minus 2 is -1. I move from the origin, +1, -1. Oops, forgot to put that in there. I'm going to keep going in the positive direction. Let's do 2 now. So 2 squared minus 2. 2 times 2 is 4. 4 minus 2 is 2. I go +2, up 2. Alright, I see I'm getting a good half of this picture. I need to get the other half. Let's go in the negative direction. Replacing x with a -1. And anywhere I plug in that -1, I'm going to put parentheses around it. So I make sure I end up with the correct signs. Here I have -1 times -1 is +1. And +1 minus 2 is -1. At the origin, I go back 1, down 1. And lastly, I want to pick another. Let's do -2. Replacing x with -2. Oops, and squaring it and subtracting 2. -2 times -2 is +4. +4 minus 2 is +2. I go back 2, 1, 2, and up 2, 1, 2. I see I have that full parabola shape. And then continuing on my graph in both directions. There you go. So those are the tricks to graphing nonlinear equations with tables.